Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're continuing our journey through Level 3, Jedi Master, focusing on internal architecture and advanced topics. We're in the chapter about ZooKeeper and Kafka coordination, and we'll be discussing the migration to KRaft, which stands for KafkaRaft Metadata Mode. Joining me as always is our Kafka expert, Victor. Hi, Victor.
Hello, Sheila, and hello to all our listeners. I'm excited to dive into this topic today. It's a significant change in Kafka's architecture that's been in the works for a while.
Absolutely. Before we get started, let's remind our listeners that to fully grasp today's topic, it's helpful to have a basic understanding of Kafka's architecture, ZooKeeper's role in Kafka, and the concept of distributed consensus. Now let's kick things off with a quiz question for our listeners. Here goes. In the context of distributed systems, what famous computer science problem does the Raft algorithm, which KRaft is based on, aim to solve?
Ooh, that's an intriguing question, Sheila. It touches on a fundamental challenge in distributed systems. I'm sure our listeners will find it thought-provoking. Without giving away the answer, I'd say this problem is at the heart of how distributed systems make decisions and maintain consistency. It's something that every distributed system, including Kafka, needs to address.
Great point, Victor. Now, before we dive into KRaft, could you briefly remind our listeners about ZooKeeper's role in Kafka?
Certainly. ZooKeeper has been an integral part of Kafka since its inception. It's responsible for maintaining metadata about the Kafka cluster, managing broker leadership, and coordinating various cluster-wide operations. Essentially, it acts as the brain of the Kafka cluster, ensuring everything runs smoothly and consistently.
That's a great refresher. So what exactly is KRaft, and why is Kafka moving towards it?
KRaft, or KafkaRaft, is a new metadata management system designed to replace ZooKeeper in Kafka. It's based on the Raft consensus algorithm, which is known for its simplicity and ease of understanding. The main reason for this migration is to simplify Kafka's architecture by removing the dependency on an external system, ZooKeeper, and improving scalability and performance.
Interesting. So, it's like Kafka is growing up and wanting to manage its own affairs without relying on ZooKeeper as a guardian. Could you elaborate on the benefits of this change?
That's a great analogy, Sheila. You're absolutely right. The benefits are numerous. First, it simplifies deployment and operations by removing the need to manage a separate ZooKeeper cluster. Second, it improves scalability. KRaft can handle larger metadata and more partitions than ZooKeeper. Third, it enhances performance by reducing the number of network hops for metadata operations. Lastly, it provides better failure handling and faster leader elections.
Those sound like significant improvements. But I'm curious, are there any challenges or potential downsides to this migration?
Absolutely, Sheila. Like any major architectural change, it comes with its own set of challenges. The primary one is the migration process itself. Existing Kafka clusters need to be carefully upgraded, which can be complex for large, mission-critical deployments. There's also a learning curve for operators who are used to managing ZooKeeper. Additionally, some third-party tools and applications that interact directly with ZooKeeper for Kafka metadata might need to be updated.
I see. So, how does the migration process actually work? Is it like flipping a switch, or is it more gradual?
It's definitely not like flipping a switch, Sheila. The Kafka community has designed a careful, phased approach to migration. In the first phase, KRaft runs alongside ZooKeeper in a special migration mode. During this phase, metadata is duplicated in both systems. Once everything is verified to be working correctly, the cluster can be switched to KRaft-only mode. The process is designed to be reversible at each step, allowing for safe rollback if issues are encountered.
That sounds like a well-thought-out process. Now, I'm curious about how KRaft compares to similar technologies in other distributed systems. Are there any interesting parallels or differences?
Great question. KRaft's use of the Raft consensus algorithm puts it in the same family as systems like etcd used by Kubernetes, or the Raft implementation in Console. However, KRaft is specifically optimized for Kafka's use case. One interesting difference is that while many Raft implementations use a single Raft group for all decisions, KRaft uses multiple Raft groups to improve performance and scalability.
Fascinating. As we wrap up, could you share any best practices or tips for teams considering or planning the migration to KRaft?
Certainly. First and foremost, thorough testing in a non-production environment is crucial. Teams should also ensure they're on a recent version of Kafka before attempting migration, as KRaft support has evolved over recent releases. It's also important to plan for adequate monitoring during and after the migration. Lastly, teams should be prepared for potential changes in operational procedures and tooling.
Those are excellent tips, Victor. Now, before we conclude, let's reveal the answer to our quiz question. The Raft algorithm, which KRaft is based on, aims to solve the consensus problem in distributed systems. This is fundamental to ensuring that all nodes in a distributed system agree on the same state, even in the face of failures.
Exactly right, Sheila. And understanding this helps appreciate why KRaft is such a significant advancement for Kafka.
Absolutely. To summarize today's episode, we discussed KRaft, Kafka's new metadata management system based on the Raft consensus algorithm. We covered its benefits, including simplified architecture, improved scalability, and better performance. We also touched on the challenges of migration and the careful process designed to address them. Finally, we compared KRaft to similar technologies and shared some best practices for migration. In our next episode, we'll be moving on to the performance tuning chapter, where we'll start by discussing broker, producer, and consumer optimization. Don't miss it. If you've enjoyed this episode, please subscribe to Kafka Internal's Crashcasts and leave us a rating. Your support helps us reach more Kafka enthusiasts. Until next time, may the stream be with you.